This video is sponsored by A&M ACT. In a standard coordinate plane, one of the following equations of a circle that can be inscribed in ellipse is this right here. Means that's the ellipse. And a lot of times students are very confused by it, but really what you're looking for, and it doesn't really matter which way it is, we're just looking at, we have an ellipse and we have some sort of a circle inside of it. So the circle's not going to be able to reach both sides. It's going to only reach the shorter of the side since it's inscribed. And so we're going to be looking at this, and you can see we have a 4 and we have a 9, and hopefully you know a little bit about ellipse. And with ellipses, we can take this 36 and we divide it through. In other words, we would have x, or 4x squared divided by 36. Plus 9y squared divided by 36, and then we would have 36 divided by 36 because we want it to equal 1. So we end up with this 9x squared, sorry, not 9, x squared over 9 plus y squared over 4 equals 1. And with that in mind, if it had been shifted to one side or another, in other words, if the center of my ellipse is not 0, 0, it would have numbers inside. So in other words, it would look something like x minus 3 squared equal over 4 or 9, okay? So, but since I don't have this, this is not a shift. So that means my center is going to be 0, 0 for both of my circle and my ellipse since it's inscribed. Well, that kind of is nice because now I can get rid of these because those mean that I have a shift going on because it's inside with the x. Now, when I'm looking at these, I need to figure out, if I look at the 9, I square root that, my radius is 3. I square root this, my radius is 2. So I'm going to go for the shorter end. So that means my radius is 2. And that means that this is going to be 4, because it's 4 squared, 2 squared is 4. So there's my answer right there. And knowing that a circle you have basically is x squared plus y squared equals r squared, where the shifts are inside the actual square. Well, if you, here it is a little bit neater, also with a little bit of a graph thing going on here, so it kind of gives you an idea of how it works and how I'm looking at it if you're not really sure what I meant. But you can see if it's inscribed, it's actually inside the actual ellipse. But there's no way a circle can go to both ends of an ellipse. One's always going to be shorter since it's an ellipse, and that's why. Give me a thumbs up if you like this channel. Also to subscribe to see more. You have a great day, and I'll see you next time. At A&M ACT Prep, we offer small classes. Visit our website, amactprep.wordpress.com, for more information and to register for our upcoming classes.